Good evening. I'm pleased to welcome you to the library's temporary space at Marshall School, and thank you for attending tonight's presentation about something that affects every single one of us, climate change. I would like to introduce our speaker, Chris Edwards, meteorologist and climate specialist. You might know Chris as the Chief Meteorologist from Fox 2 Detroit from 1987 to 2004, or as a meteorologist on WXYZ from 2011 to 2018. He truly has a lot to tell us about the seriousness and urgency of this issue, as well as simple ways that we can help to solve many of the problems we are facing and will face in the years to come. Because of his important work, he has been awarded 3 Emmy Awards for environmental reporting and weathercasting, as well as recognized by the Michigan chapter of the National Association of Television Arts and Sciences. Thank you, Chris, for sharing your knowledge with us, and I hope you all enjoy the presentation.
Thank you, Aubrey. I appreciate that. And thank you guys for being here. I appreciate you coming out on a beautiful spring evening. We are going to talk, as the slide gives us a pretty good clue, about our changing climate. Honestly, before I get started though, I really wish that I could stand up here and instead tell you some interesting, funny stories about my TV career, working with people like Bill Bonds and Rich Fisher and who else? Huel Perkins for many years, and Glenda Lewis, and those were people with whom I got to work and share some amazing times and experiences. Maybe some other time if I would get invited back. Unfortunately, what we have to talk about tonight is really more important, but I promise it won't all be gloom and doom. Just like some of my stories might be interesting to hear about the world of TV for many years. Some of the things I'm going to talk about tonight are simple, and some of them are concerning, because I'm going to be completely honest with you. But there is also a third part of what this program is, and that is solvable, and we'll talk about that as well. There is reason for hope, and I'll tell you that right off the bat. As we get started with the slides, however, oh, and by the way, if you have questions, if you could, please hang on to them. If you think that there's no way you're going to remember, then go ahead and raise your hand during the slides. But believe me, I'm going to leave time for questions. I recognize that you're going to have questions. And after the slides, I will entertain questions as long as they come. And the great part about having a relatively small group is that everybody that has a question will probably get an opportunity to ask that. So, that being said, I want to thank, at the beginning, Climate Central there in the lower right, because Climate Central is a policy-neutral, nonprofit news organization that analyzes and reports about climate science. That's all they do. Now, I've been working with their meteorologists since 2008, which is when they got started. And the presentation you're going to see this evening is a presentation of facts that are derived from the latest scientific consensus. And that is the case up until the very last slide, which is something more than just facts, and we will get to that. As I mentioned, what we're going to talk about tonight, the title of the presentation is also a brief outline, because climate change is at its core simple, in spite of what you might have heard otherwise. It's serious and it's solvable. Simple meaning that we understand the problem and have for a long time. Serious means it's having impacts already and will continue to, and solvable means we know what to do to move ourselves away from this. So let's start with the simple, because I think simple is a good, reasonable place to start. And the basic fact about climate change is that humans burn fossil fuels. And by that I mean coal, oil, and natural gas. And we've been doing that in increasing amounts since about the mid-1800s, more or less, the dawning of the Industrial Revolution. We've been releasing this CO2 into the atmosphere. CO2 and carbon dioxide, same thing. I'll use them interchangeably. Carbon dioxide is a greenhouse gas, and it makes the planet warmer. And that is the simple version. Into a little bit more detail, though, let's talk about our atmosphere and what it's made of. Well, 99% of it is nitrogen and oxygen, and obviously that's a whole lot. But the small, what are called trace gases, have a huge impact on the atmosphere. Even though they make up only a small part of the atmosphere, the carbon dioxide, methane, and to a lesser degree nitrous oxide. These are important greenhouse gases, and it's these two that we are putting into the atmosphere in very large amounts, causing significant change. They, even though they are small in number, have a big impact. And the reason they have a big impact is of something called the greenhouse effect. Now, a lot of us learned about the greenhouse effect perhaps in middle school or high school. The greenhouse effect is and has been around a very, very long time, and it's a good thing. Sometimes people confuse the greenhouse effect with climate change or global warming. They're not the same thing, but they're clearly related. So here's how the greenhouse effect works. Sunlight, even though the sun is many millions of miles away, reaches the Earth. It reaches the Earth, and some of that energy is reflected back up into space. However, some of it is absorbed and it is re-radiated as heat around the globe. And as that happens, most of the heat is absorbed by the greenhouse gases and then radiated in all directions, warming the Earth. Just like a greenhouse is warmer than the surrounding areas, so the greenhouse effect keeps our planet warmer than it would otherwise be. And don't be mistaken, it's a really good thing we have the greenhouse effect. If we did not have the greenhouse effect, the average global temperature would be about 0 degrees Fahrenheit instead of about 60 degrees Fahrenheit where it is now. That number, of course, is going up, but life marginally would be possible with 0 degrees Fahrenheit, but nowhere anywhere close to what it is now, and not nearly as easy as what it is now. Now, evidence about greenhouse gases has something that it's something we've known about for a very, very long time. Some key discoveries going back about 200 years. Joseph Fourier from France, back in the 1820s, actually proposed at that time that there were gases in the atmosphere that were keeping the Earth warmer than it would be without them, and that's 200 years ago. Then in the 1850s, Eunice Foote from our country actually discovered that carbon dioxide warms the air around it. And I have to just very briefly give a little shout out to a woman in science in the 1850s. Imagine the obstacles that she overcame to be an important discoverer in science. And I will just say that women in science continue to do amazing things, and I want to support them whenever and however possible. So yay for women in science. So then in the 1890s, Svante Arrhenius actually took things quite a bit farther. He calculated that a doubling of atmospheric carbon dioxide would raise the Earth's temperature several degrees. Again, that's about 130 years ago. And then in the 1930s, Guy Stewart Callendar was the first one to actually make specific detailed climate predictions. And he assembled the first evidence of global warming. So important is his work that a lot of climate scientists still call the whole thing the Callendar effect. But the point here is that we've known and have been refining our understanding of carbon dioxide as a greenhouse gas for a very long time. So carbon dioxide plays a critical role in regulating the temperature of the planet. In the 1800s, as I mentioned before, humans started putting more fossil fuels, first coal and then oil and natural gas, into the atmosphere. Now, doing so fueled the Industrial Revolution worldwide, which raised the standard of living for millions and millions of people. However, if Callendar and the others were correct, we would expect to see the temperature rise as the CO2 rises, as the carbon dioxide rises. Well, let's just take a look at that. This is just carbon dioxide. This is a plot beginning about 1880 and going up to recent times. Our most recent carbon dioxide plots are coming in around 418, 419, something like that, which is fully 50% higher than it was in pre-industrial times. So that's what carbon dioxide, in, by the way, for those following along, that's in parts per billion. That says parts per million. Well, anyway, the carbon dioxide level has clearly been going up. So look what's gone on with the temperature during the same time. And let's take a close look at that. Although there are rises and falls off of the line, there's no doubt about that. It's pretty clear the relationship between the two. As carbon dioxide is increasing, it's causing the planet to warm, as predicted, as expected. Now, This is a little longer period of time with carbon dioxide. This is going back not 140 years, but 800,000 years. And we can see what carbon dioxide levels have been. Basically, in pre-industrial times, kind of a baseline is 2.25, something along those lines. But you can see not only how we have, once we exceeded 300 parts per million, it must be ppm. I was thinking of another product in the atmosphere. Once it exceeded 300, we were in territory we haven't been before. And we did that in 1910, approximately. Today, again, it's well over 400. It's continuing to go up. So, among other things, we're far, far higher in carbon dioxide in the atmosphere than we have ever been for at least 800,000 years. And there's a lot of pretty solid evidence going back about 2 million years that we're much higher than we've been in that time. So when people say climate changes, it has always changed, that is true. It is. It is changing. It has always changed. A key point for us to remember is that we have not in recorded history, and certainly not in the length of time that we've had human civilization on this planet, have we been anywhere near where we are now. And the other extremely important point is how quickly we rose. In the past, the climate would change, and it would change relatively gradually. This has been almost, on this scale, just a meteoric rise. Sometimes it's called a hockey stick because it looks just a little bit like that. Now, a brief word here on methane, because I've mostly been concentrating on carbon dioxide. And here's the ppb. Forgive my, this is parts per billion. Forgive me for getting those confused for a moment. Methane is getting more attention lately, and with good reason. It is another important and potent greenhouse gas. This is the methane concentration in the atmosphere just back since the early 80s. But it's clearly going up as well, from under 1650 to over 1900 and latest. Now, methane is important for a couple of big reasons. It is, molecule for molecule, a more potent greenhouse gas. So the same amount of methane warms the atmosphere considerably more than the same amount of carbon dioxide. That's the bad news, because we're releasing a lot of methane as well from a lot of different sources. The good news is that if we stop releasing methane, or any methane that's been released, it only lasts in the atmosphere for about 10 to 12 years. 10, 11, 12 years, something like that. So, if we stop releasing the methane in 10 to 12 years, it's not an issue anymore. We can't say that about carbon dioxide. Unfortunately, CO2 stays in the atmosphere for hundreds of years. But methane, and a reduction in the methane, which is a critical part of how we move forward, it's almost like kind of a low-hanging fruit. This is something that can be reduced, I'm not saying easily, but when it is reduced, we get payoff quickly compared to carbon dioxide. All right, so let's bring this to home a little bit. So some of us in the room might have recollections going back to some of these decades here. This is just the average temperature in Metro Detroit going back to the decade of the 70s. You know, disco. Anyway, average temperature about 48.5 degrees. That's all days averaged out over the entire decade, highs and low temperatures combined. And it went up noticeably in the 80s, really jumped up in the 90s, and went up just a little bit in the aughts, okay? And then another big jump in the 2010s, to where, on the Fahrenheit scale, we in Metro Detroit are about 3 degrees Fahrenheit warmer than what we were in the 70s. Now, that is a faster warming than the global averages. And it's really not that big a deal because we are a small pinpoint on the entire Earth. But I show this to you for a couple of reasons, and not the least of which is if you have recollections that things were colder when you were younger, you're right. It's what has happened. We here locally have warmed, and warmed rather significantly in a relatively short period of time. And the seasons that we've seen the warming are not all the same. The greatest amount of warming has actually happened in the Metro Detroit area in the winter. It's been much more modest in the spring, and then it's pretty considerable in both summer and fall. We'll talk about implications for that as we move forward, but that's just a little breakdown by season of how things have changed here. Now, the future is what we can talk about. We have sophisticated computer models, and by the way, I started studying climate change and climate science back in the mid-80s. Specifically, it was 1987 that I started working on it and then reporting on it extensively starting in '88 when the entire Great Lakes region had an extremely hot summer and a terrible drought in the summer of '88. And that's when I started working on this, and at that time it was still a lot about theories about what was going to happen. We had increasingly sophisticated computer models that weren't nearly as good as what we have now, but they were saying, well, if we continue to put the CO2 into the atmosphere, we're going to warm. And that is what indeed we have seen. They predicted, starting back in the '80s, the computer models predicted the warming we have, but they tell us two important things: that lots of CO2 emissions, if we continue, will lead to considerably more warming. This is the path we're on. But this is where the warming would be if we make significant emissions cuts. So just really making the point here that the future depends on what we do now, but also the point, and it's a sober point, that some of the warming is already baked in the cake. If we stopped our emissions right now, which is obviously impossible, but if we did, there would still be some warming. But the amount of warming, the severity of the warming, the rapidity of the warming, that is all partially up to us. The longer we wait, the worse that it will get. All right, so that's the simple part. Let's talk a little bit about serious, because it isn't just warming that we're seeing, because warming leads to other changes in the atmosphere and in the oceans. That's climate change rather than just global warming. We're already seeing warming leading to wilder weather and to rising seas, and we'll talk just a little bit about that. Important to note here that we've been talking about averages because averages are fairly easy to understand. But it's also important to realize that when we slide the average over, two different things happen. That means we get more considerable heat and more extreme heat. And on the flip side, we get less considerable cold and less extreme cold. That doesn't mean it can't still be extremely cold. It doesn't mean we can't have snowstorms. Indeed, in some instances, we have more snow because of climate change, and we'll talk about that in a bit. But the point here is that even though averages are where we focus most of our attention, the extremes are what we're seeing more on the hot side and we're seeing less of on the cold side. Those small shifts lead to the large differences in extremes. Now, it isn't just, oh, by the way, on this point, I'm sorry, I wanted to make a point with the previous slide. In terms of global temperatures, the hottest 8 years on record, in our historical record, worldwide, the hottest 8 years that we've ever had have been the last 8 years, since 2014. So there's no doubt when we look at temperature data around the world, on land, oceans are warming as well, but we'll talk about that separately. There's no doubt what we are seeing, all of the 8 warmest years have been in the last 8 years. All right, so now let's talk about something other than just warming. We keep track of things called billion-dollar disasters, and this is just in this country. Obviously, there's impact worldwide, but this is just in this country. When a disaster related to weather causes $1 billion in damage, it gets a little notch, and we've kept track of those sorts of things for a long time. And for many, many years, the average number of such events was around 7 a year that caused $1 billion in damage during the course of an average year. And by the way, these are inflation-adjusted dollars. I know a dollar now doesn't buy what it did 30 years ago, but that's worked into this. In 2017, we saw for the first time 2011 is the first time we saw 16 such billion-dollar disasters in this country. Then we got a little break, and then 6 years later, again, we saw 16 of them. We had not seen those kinds of numbers for billion-dollar disasters up until that time, the 2010s. And most recently, in 2020, we had 22 of those disasters. I'm talking about things like hurricanes, severe weather outbreaks, ice storms, things like that. In 2020, when we had 22 of them, that set a record. Now, obviously, we were pretty distracted with the pandemic in 2020, but along with that going on, we had billion-dollar disasters at a record level here. Then in 2021, we had 20 of them. So just shy of that in 2021. And some of those were severe weather outbreaks in December in the Ohio Valley, which we had never experienced before. We didn't really think that, we meaning the meteorological and climatological community, didn't really think that you could get severe thunderstorm tornado outbreaks in the Ohio Valley in December, but we did. And unfortunately, it took a lot of lives. These are just dollars, I want to point out here. This is not human impact, which obviously is incalculable, but we're talking about dollars. And then in the recent year, the year just completed, 2022, we had we haven't put it on the slide yet, but we had 18, so it's going to go right about here. We had $18 billion disasters in 2022. One of them caused $113 billion in damage on its own. Any guesses on what that was? You don't have to know, I just wanted some water. When Hurricane Ian made landfall in Southwest Florida, it produced an estimated $113 billion in damage. That's going to take a long time to get worked out. So one of the points here is when sometimes people say, very, very rightly, that making the changes that need to be made is going to be expensive. It is going to be expensive. But I would suggest to you that just in dollars and cents, so too is not doing anything expensive and getting more expensive. And again, that's before we talk about human toll. So snowfall patterns are changing. I touched on this a little bit before. We are in a climate that gets snow. Will we stop getting snow because of climate change? No, that's not expected. It's not expected for a long time. What does happen is that temperatures are more frequently above freezing. Now, late fall and early spring snow might fall as rain, but here's an impact that you might not have thought of. The ice storm that we had here last month that knocked out power to 500,000 or so people and was devastating in so many ways for so long, that particular storm, if we had been 1.5 degrees Fahrenheit warmer a couple thousand feet up, which I don't want to get too nuanced about the meteorology, but not far from where we live, just a little bit higher in the atmosphere, it was a little warmer than we would have liked it to be. Had it been 1.5 degrees cooler, everything that fell would have been snow. We would have had an 8 to 10 inch snowstorm. Oh, impactful for sure, but it doesn't knock out power to 500,000 people. That is an example of how the patterns that we become used to can change, and sometimes not for the better, as you warm the atmosphere. You change precipitation patterns. Now, there are other changes to precipitation patterns. For instance, out west, a lot of mountain locations, more of their precipitation is falling as rain, which it can't be stored then and slowly used throughout the season because it just runs off. And that leads to some problems with water sources out west. And then temperatures may still be below freezing, but warmer air can hold more moisture. And as strange as this may sound, a warmer environment can actually lead to heavier snowfall because the atmosphere can have more moisture and it can therefore produce heavier snow. And that is definitely the case with lake effect snow, which we get around here. We can actually have more intense lake effect snowstorms because the lakes are warmer and stay that way longer into the winter, and we have seen that. Again, these are ways that weather is impacted not just because of warmer temperatures. Well, it starts with the warmer temperatures, but it has impacts that are more than just the warmth. All right, just 2 pictures 7 years apart of a glacier. Truly, I could show you pictures from gorgeous glaciers all over the world and in the high mountain territory of different parts of the world as well that look something like this. I'm just giving you one brief example. Warming is melting glaciers and doing it very quickly. It's important to note that the polar regions, North Pole, South Pole, are warming 2 to 3 times faster than our part of the world. And the populations that live there have a very different outlook on what climate change is. They don't think about it as a thing that's coming. They've been dealing with it for a while, and it's having radical impacts on the way they live that are too numerous to even go into, but they are very significant. And in just 7 years' time, this is the Bear Glacier, by the way, in the, it's in the Kenai Fjords National Park up in Alaska. But again, we're seeing this in the Mountain West in the lower 48. We're seeing this in the Alps. We're seeing this in the Antarctic as well as the Arctic. Very rapid retreat of glaciers, which among other things is a problem because many people rely on those glaciers for their drinking water. All right, we've been talking about land up to this point, but the oceans are heating up too. Over 90% of the extra heat that has gone into the atmosphere has actually been absorbed by the oceans. They've sort of taken some of the pressure off of those of us that live on land, but the oceans play a critical role. They're actually where the currents go that drive weather patterns. Ocean currents are the ones that drive jet streams, which drive weather patterns. The Gulf Stream, which you probably heard of, goes up the eastern coast of the United States and North America, up in here, and then it goes over into Western Europe, and then it circulates back down as a cold current from north to south. And as the oceans of the world warm, wherever you see this orange or reddish shading, those are warmer temperatures over the data period, which is about 120 years. Okay, this area down here, that's a data void. That's not, it's gotten colder. We don't really have good data on what's going on down there, but where we do, this is what's going on. Now, does anybody see something that kind of stands out on that map that looks for the ocean? Remember, those colors that you see here, these are what's happened to the ocean temperatures over 120 years. And the red is all over the place. Blue is getting cooler. Anybody see anything that stands out?
Yeah, Greenland?
Yeah, it's blue with green.
Thank you. Thank you for spotting that. Yep, there it is. I know when I first saw this map, or a map like this, I thought, what's going on there? Maybe there's a data problem. Maybe they've got, no. What's going on there is Greenland. You mentioned the word Greenland. Covered with ice. What's happening to that ice? It's melting very fast, and it's dumping into the North Atlantic Ocean, when it didn't used to do that at anywhere near that rate. So what we have in the North Atlantic is a persistent cold pool of less salty water, because it's fresh water that's going into it, that didn't used to be there. It's colder than it used to be. And remember, I just said that the ocean currents drive weather patterns, and this is the area that storms come from that affect especially Western Europe. So this has, that effect there has a fancy name, the AMOC, the Atlantic Meridional Oceanic Circulation, which probably won't be on jeopardy, but it's important because we are changing the planet, and we do, when I say we, I mean the climate and meteorological community, we do not know what that's going to mean. We don't know. We're basically doing this big experiment. We have some theories about what's going to happen. We have some theories that it's already impacting weather patterns in Western Europe in a significant way, but we really don't know. And unfortunately, we're not going to be able to stop the experiment anytime soon. We're just going to have to see what plays out. The other important point here is that I mentioned that some of the pressure has been taken off land because the oceans have absorbed so much of the extra heat in the last 100 years. Unfortunately, the oceanographers are telling us that the oceans are pretty much getting to the point where they're saying, that's about it. We can't absorb a whole lot more of that. That's about it. As they absorb the heat, the molecules in the ocean expand, which is part of the reason you get sea level rise. We'll talk more about that right now. Because sea level rise is also a part that you might have heard about climate change. This is the last 2,000 years, and one bar per century. So not long after 1 AD, the ocean level went up an inch or so, and then it stayed the same for 100 years and went up a little, down a little. It's kind of a significant drop there in the 11th century. But basically, it up or down, not far from baseline. And then, whoa, look at that. The last 100 years, we have seen an unprecedented sea level rise compared to the previous 19 centuries. Now, is it 3 feet? No, it's just under 6 inches. But compared to anything we've seen in 2,000 years, it's significant. And the reason is not so much melting glaciers like Greenland and Antarctica, but it's the fact that warm water takes up more space. That's a basic thing of physics, and warm water takes up more space, so when you warm the ocean waters, you expand them, and the sea level goes up. It's really, really as simple and as challenging as that, because the sea level is going to continue to rise, and hundreds of millions of people live at an elevation of 20 feet or less sea level, and that impacts them in a major way. As you might expect, the higher the tides, the more flooding you get. You have a higher sea level, the tidal impact is greater, so then you have more flooding. These are number of days in the United States of flooding and how it's changed over the last 50 years. It's gone from about 12 to about 22 days of flooding. That's the smoothed average of that particular piece of information. Now, obviously, we don't care much. I shouldn't say we don't care. We are not directly impacted by that much here in Metro Detroit because we're not near sea level. But anybody that knows anybody or has any interests or has any concern about parts of the country, like for instance South Florida, where they have what they call sunny day flooding, and it's exactly what it sounds like. There's no storm, but it floods anyway because the sea level has come up so much that it doesn't take a storm to produce flooding, and that is a huge challenge. Really important part of understanding climate change is the relationship between temperature and the amount of water that the atmosphere can hold. I touched on this briefly, but it's really important for us to understand that a warmer atmosphere holds more water vapor. And that's why, to relate to this, that's why it's more humid in the summer. We don't feel that it's uncomfortably humid in the winter because colder air can't hold as much water. But in the summer, that warmer air can hold more moisture, and it does, and we feel the humidity in the summertime. So an increase in temperature allows more evaporation into the atmosphere from all kinds of surfaces, oceans, lakes, soil, even soil and plants. More moisture is available for storms. And remember, most of the planet, over 70% of the planet is water. So this effectively supercharges the water cycle. If you warm the temperature 1 degree Fahrenheit, it can hold 4% more water vapor. And we've done more than that on the planet already, as we've seen. So when you hear about storms being more intense, rainfall being more intense, we'll talk more about this later, part of the reason is that we have a warmer atmosphere, and as it continues to warm, it holds more moisture. You supercharge the water cycle, you can allow intense rainfall to be more intense. And conversely, and this is the part that some people have a little trouble getting to understand, on the flip side, drier areas can get drier because if the moisture isn't available, the atmosphere may be able to hold more moisture, but if it isn't there, then what you have when you warm the atmosphere is a hotter environment, generally with fewer clouds, and it allows drying to happen more quickly and drought to spread and become more widespread. So wet areas get wetter, and there's a potential for extreme drought that is greater than it was before. The two can be true at the same time. Let's talk about the downpour part. By region, I'll just be very brief on this. How much more, what kind of an increase in heavy precipitation we've seen in our part of the country? About 42%. This is over about a 60-year period, if I remember. Let's see, 40, yeah, about a 60-year period. In the Northeast, actually a little bit more increase in heavy precipitation events, and then lesser amounts in the South, West, and almost nominal amounts in the drier, particularly the drier sections, and then the traditionally wet climates of the Pacific Northwest. They have not seen quite as high an increase in precipitation events, but if you wonder about the relationship between heavier storms and climate change, it was predicted, and it is being seen, and it's being seen more and more frequently, not only around here, but in other parts of the world as well. Speaking of that, more intense rainfall. This is Metro Detroit, average hourly rainfall in hundredths of an inch, basically over a 50-year period. So what this is showing us, when it rains, how hard is it raining? And that's really what this is showing us. And in that 50-year time period, you see when it does rain, it has become heavier, going from about 4.7 to about 6 in the metro area. Now, that is the average. Remember, though, the extremes, which can be significant. June 25th and 26th of 2021, some of you may have had your homes or somewhere very close to you that flooded in the very heavy rains in June of 21. In the border between Detroit and Grosse Pointe, it was even worse. The peak, in 24 hours, they got 8.2 inches of rain. 8.2 inches of rain. There is no system that can handle that kind of rainfall. Honestly, we didn't even think that kind of rainfall was really possible until recently, and obviously it was overwhelming for those areas. And in that particular rainstorm, you might have had problems here. Even though it didn't rain as much, I think rainfall in this area was closer to about 4 inches in a short period of time, but that's still way too much, even though it's only half of the 8.2 they got in some places. More intense rainfall is being seen in a lot of places. The monsoon season in Pakistan last fall was one of the worst they've ever seen, and unfortunately many hundreds of people lost their lives because of the intense rainfall that they saw there. A brief couple of words on hurricanes. And one of the biggest reasons, I mentioned Ian earlier, when Ian made landfall in September, tremendous amount of news, and a lot of it mentioned climate change. And, you know, in general, to increase the awareness is a great thing to do. Unfortunately, I told you at the very beginning this is facts, and we're going to deal with facts. One of the things I heard often on different media outlets, again and again after Ian, was something to the effect of this: with climate change, we can expect more hurricanes, right? And that is not true. That is not what the science shows. And I told you I would deal with facts, and that's what we're dealing in, facts. Now, the research actually shows that we will either see a similar number of hurricanes or maybe even fewer, a slightly smaller amount. Unfortunately, that's the end of the really encouraging news, because even though there won't be more hurricanes, the ones that do form are expected to be more powerful and last longer. And those are not good things, to be more powerful and for them to last longer. Also, it's important to note that the heavier rain that we talked about in general certainly has an impact with hurricanes too, so you're going to get heavier rain than you otherwise would in hurricanes. And because, if for no other reason than the fact that the sea level is higher to begin with, the storm surge can be more significant. Now, if you also have a more intense storm, then that also builds on the storm surge. But I want you to be clear, if you hear that again, somebody that says more hurricanes because of climate change, that is not what the current state of the science states. Now, it might change, but that's not what the evidence shows. Very briefly, really interesting research in the last 3 or 4 years has shown that the hurricanes that do form tend to slow down more in a climate change world, and also that they can rapidly intensify soon before landfall. Those are bad things if you live near the ocean, because that's slowing down. I mean, think about it. If you've got a horrendous storm, do you want to move through it 10 miles an hour or 25 miles an hour? Get it out of there. You want it to move faster. Unfortunately, the evidence is showing and the models are strongly hinting that we're going to see more rapidly intensifying hurricanes and those that move more slowly than they did before. All right, on the flip side of the coin, let's talk about drought. And this is the western U.S. I'm going to be brief about this, especially because it doesn't impact us directly, but this is the intensity of drought going back to 1900, where you see a line, you've got some kind of a drought, and this shows you how long it lasts. So periods of drought, especially in the western U.S., have been going on for a long time, but they're getting deeper and longer. And indeed, the drought that existed, and I'm now speaking in past tense because of what's gone on this winter, but the drought that existed through a lot of the western United States was the worst in 1,200 years by most any measure. Incredibly, incredibly bad. They were and still are thinking about a lot of radical ideas on how they're going to have enough water to drink out in the western United States. This is drier areas getting even drier. Droughts that previously existed getting more extreme and lasting longer. I say past tense because the parade of storms that has hit the western United States in the last 3 months is almost unprecedented, and it is knocking a lot of that drought down. It's too much too fast, but it's knocking a lot of that drought down. And the snowpack in the Sierras, for instance, is the second highest they've ever recorded right now. 1951-52, they had an incredible year out there. But if current trends continue, they may even challenge that. But it's gone a long way to knock out the drought. But again, climate change theory and reality that we've seen is one of the things we also see is quickly going from one extreme to the other. And so we go from the worst drought in 1,200 years to the most intense precipitation that we've seen, the second most intense precipitation we've seen in 140 years of record keeping, literally back to back. And those extremes are something we're seeing in a lot of different areas as well. So just a couple other things about serious impacts, because we've been talking about humans and impacts and civilization, but we need to remember, of course, that we're not the only species that is impacted here, because climate change impacts the natural world in huge ways, and just a couple of them that I want to touch on. Animals they're adapted to specific climatic conditions over a long period of time. As the climate warms and warms rather quickly, many of them are moving north or poleward, or they're going to higher elevations. They have to do something to adjust. These seasonal cycles get disrupted. Plants bloom earlier in the spring, and then the mismatches between predator and prey develop because the plants bloom, but the things that come there and feed off the plants aren't there yet. They haven't adjusted so quickly, and then you get these mismatches. And then there are some ecosystems, like coral reefs, that are impacted severely by heat waves in the oceans, and they are already severely impacted, and they will continue to be if the oceans continue to warm quickly. So just a little reminder that there's more than just us, but why not? Let's go back to us. Climate change is hurting human health in ways you may or may not have thought of. Warmer conditions make air pollution worse. One of the reasons for that is that we have more wildfires, but that's just one of the reasons. Burning coal and diesel, CO2 sources, those don't help with air quality. We've known that for a long time and been working on that for a long time. But the heat impacts us directly, making things like physical activity outdoors or working outdoors. Athletes, outdoor workers have to be concerned about that as well. Certainly people with asthma. Mosquito and tick-borne diseases like Zika and malaria, Lyme, are spreading to new locations, and they stick around longer than what they used to do. Longer allergy seasons. I just saw a report on the NBC Nightly News last night about the lengthier allergy seasons by about 30 days on average around the country. About 20 days of that is at the front end, 10 days of that on the back end. Not only lengthier seasons, but the intensity of the pollen release is higher. So anybody with allergies is impacted by this as well, and even something like poison ivy. There's evidence that shows it's more widespread and potentially more irritating. Farming, agriculture, huge impacts. There's going to be a big gathering this summer here in Michigan, a nationwide gathering, because there's a lot of work being done in Michigan about how we do our agricultural practices differently in a changing environment. But how we produce food, and the people that work on the farms, the wild weather like flooding and drought obviously impacts that sort of activity. Planting zones shift northward or toward the poles around the world. And then crop diseases and pests are spreading and sticking around longer than what they used to do. All right, so we did the simple, we did the serious, check. Okay, now the part that is actually my favorite, that I've alluded to a couple of times, is the solvable, which is a good time to take a little breath. It is important, though, to recognize that as serious as these problems are, that there are solutions, and we'll talk a little bit about those. In short, I'll just tell you straight up what I alluded to at the beginning. This is going to be very challenging. This is not going to be an easy thing to do. But basically, we need to reduce CO2 emissions, and we need to do it fast. This is the path we've been on in terms of rising temperatures. And if we stay where we're doing now, 4 degrees C is about 8 degrees Fahrenheit. And I apologize, some of these are in Fahrenheit and some are in Celsius, because internationally we use Celsius, but we in our country are used to using Fahrenheit. So roughly double the C, so it's about 8 degrees Fahrenheit. If we don't make significant changes by the end of this century, we're in this area. I don't even want to talk about what that would mean to human civilization, because it's just really not a pleasant topic. On the other hand, if we make cuts in emissions, we might be able to keep it under about 3 degrees Fahrenheit of warming. Most estimates suggest what we need to do is stabilize the CO2 by 2050, which may seem like a long time, but it's really not, because we're talking about global changes that have to happen. We have to reduce emissions quickly, and we have to make some efforts to remove some of the carbon dioxide from the atmosphere. So to get a handle on what we have to do, let's first look at what it is. Where does it come from? In this country, this is United States, the different sectors and how much of the greenhouse gases each produce. Now, the biggest chunk, barely, is transportation, getting us from one place to another, us and the things we like to have, moving them around, 29%. Almost as much from electricity generation. That's a pretty big chunk. And then industry itself is also almost a quarter of the emissions. Commercial and residential greenhouse gas emissions are 12%, and then agriculture is about 9%. The good news is we have solutions to reduce emissions from each of these sectors. Each is, of course, a different story. But let's talk a little bit about renewable energy, sometimes called clean energy. Let's call it renewable. And these are two of the sources which have been increasing the fastest. On the left is solar energy. And what this map is telling us, the darker the shading here, the more solar energy comes to those areas. So as you might expect, the southwestern U.S. gets the most of it. Florida, a pretty good chunk too, in other parts of the South. But even in our part of the world, those are pretty significant amounts of solar energy, or times when the sun shines. But it is most significant in the western U.S. And then there's wind energy. The darkest shades show where the wind blows the most and the hardest on average. From the eastern Rocky Front Range out to the western high plains is where it's strongest, but it's significant in a lot of areas. And just a couple of brief notes on wind and solar. In the last roughly 10 years, we have seen the cost of solar reduced by about 90% and the cost of wind by about 70%, just in the last 10 years. It has been significant, and there was just a report put out yesterday that in 2022, for the first time in this country, renewable energy we had more production of renewable energy on the grid than coal for the first time. We've crossed over that line, and that's a milestone, a significant one. We have to electrify transport. We know how to produce electricity from renewable sources. We're doing it more and more. We can use that energy to move us around. A lot of attention is paid to EVs, or the electrical vehicle market, particularly in our area. But we need to convert cars, buses, trains, other modes of transportation from fossil fuels with internal combustion engines to run on clean electricity. Now, electric vehicles are cheaper. They're getting better and cheaper. They're not cheaper than an ICE vehicle, but they are getting cheaper. And the battery capacity is growing. There are more places to charge them. We have a lot of infrastructure work to do, but we are on a path. And I found this particular stat fascinating. Sometimes we lose track of how quickly change can happen when it's concentrated. In 2016, the whole year of 2016, at the end of the year, there were 1 million EVs on the road worldwide. 1 million EVs in 2016. Now we're 7 years later. We put over 1 million EVs on the road just in the last 3 months of last year. So it is really ramping up. It's doing it here, it's doing it in Western Europe, and some companies, like GM and Ford, have made not just public relations commitments, but real, genuine commitments to, for instance, GM is going to be an all-EV fleet by 2035, and carbon neutral as a company by 2040. Those are really significant targets. Would it be great if they were sped up? Yes. Who knows? Maybe they will be, but they're certainly on the right track. We use energy to heat and cool our buildings. Simple things like improving insulation saves money and energy, and it increases comfort. Electric heat pumps. I know there's not a lot of us in there. How many of you have heard of electric heat pumps before? Mm-hmm. I didn't know much about it a month ago either. And I'm no engineer. Electric heat pumps, I can't go into detail because I don't understand it. But basically, they are a way to heat and cool buildings that does not use anywhere near the energy that we do. We don't have to use natural gas. They use electricity to heat buildings. They can be used in this climate. They're exploding in popularity in Western Europe, and they're starting to come online here. The issue with electric heat pumps, which could replace your furnace or your air conditioner, the issue with them is that they are significantly more expensive at the outset, significantly more of an investment. But then your energy costs moving forward are quite a bit lower. And so over time, they actually save money, and they are much, much healthier in terms of greenhouse gas emissions. And you will be hearing more about electric heat pumps in the next year or two, because they're going to be more and more prevalent. Of course, we can reduce emissions with different farming practices while also creating better crops. Now, Better agricultural practices can lower methane emissions, which I talked about before as being very important. Rice farming and raising sheep and cows creates a lot of methane emissions. We can reduce tilling and planting and plant cover crops, which can keep the carbon and water in the soil, which is where it's not doing damage if the carbon is locked up in the soil. And even composting can make a difference. We want to maintain natural carbon sinks and flood buffers, things like wetlands, peatlands, and forests. The more of these that we can maintain or restore, the better. It's part of the solution. Coastal wetlands lands also help to buffer flooding. Now, do we have a big challenge? Of course we do. We've lost a lot of these spaces that are going to be difficult to replace, but we can maintain the ones we have and replace them where it's humanly possible. Back to Detroit. Just in the Metro Detroit area, the power of trees, what they're doing, these are the trees that are in existence. And we've lost a lot of the wetlands in Metro Detroit, obviously, since the 1800s. But even what we have, the trees remove almost 2 million tons of carbon dioxide in a year. They fight off 5 billion gallons of stormwater runoff, prevent that, and take 55 million pounds of air pollution absorbed out of the atmosphere. And the mayor of Detroit, in the fall of last year, announced a plan that by 2027, they're going to plant 75,000 trees in Detroit. And is that going to solve our problem? Absolutely not. Absolutely not. But I think of the old saying, it's called a Chinese proverb, but I don't know that for a fact. The very best time to plant a tree is 20 years ago. The next best time is tomorrow, or today, but it's a little late. It helps. It makes a difference, both in terms of what it does for the atmosphere and also the message that it sends. So it's got both of those things. So as we get ready to wrap up the slides here soon, I just have to take a moment to say, this is going to be hard. This is a global problem on the scale of which we have never tackled as a planet before. Never. We've also never studied a problem as intensely as a planet as we have this one. Okay, so with those challenges in mind, in order to keep our warming under about 3 degrees Fahrenheit is going to mean a tremendous amount of coordination and big changes that need to be done quickly. We've squandered decades arguing about things. And it is no longer a time to squander time or to bicker. But we've done big things in the past, and that's what I want to show here. I mean, just the basics of indoor plumbing and electricity. When they came to cities around the world, almost instantly you doubled the life expectancy. A huge change that a lot of people didn't think could possibly be done. Oh, the Romans sort of did it a long time ago, but we can't do this on a grand scale. That's what a lot of people said, but we did. How about the space age? I mean, when Kennedy said, we're going to put a man on the moon before the end of the decade, they thought he was crazy. There's no way possible. But one of the other things he said was, we're not going to do it because it's easy. We're going to do it because it's hard. And what we have to do here is also hard. But you know what? We did it with the space age. And how about the information revolution? A little perspective again. The very first iPhone came out less than 16 years ago. 16 years ago. Really, that's not all that long, but what has happened with the revolution of information and the internet and technology around the world, it has revolutionized the way hundreds of millions of people live their lives. So we have done big things before. Exactly like this? Absolutely not. But reducing emissions really is a win-win. It is disruptive, yes, but it creates jobs and new industries, and it prevents some of the things that we don't even want to think about. Change in heat trapping emissions, I just want to show you this. This just came out. This is just a little idea of what we can do by showing you what we've already done. Here in Michigan, we've dropped emissions by about 20%. The percent change between 2005, which is often used as a baseline, and 2020. So in 15 years, we've dropped our greenhouse gas emissions in our state by about 20%. The darker states have done better, and then there's a few states that are moving the wrong direction. But this is what we've already done. What can we do in the future? Well, we have to work on it. And I give up any time I possibly can to talk about this issue because I think it's that important. And why? Why do I work to combat climate change? Those two are the biggest reasons, son and daughter, and their children, yet unborn, are a part of the reason, but their lives are going to be hugely impacted by what we do or don't do. And I think each of us in the room might have one or more reasons why you can think to combat climate change. And I want to just go back briefly to a little idea here that talks a little bit about fairness. Before we started, we were talking a little about Greta Thunberg, the Swedish 20-year-old who has made climate change much more on the global scene than it would have been without her visibility. She's in a young generation. But this is impact by generation. These are roughly, this is the amount over the course of an average lifetime of how much warming will be dealt with by the different generations. And if we don't make significant changes, the generations of people younger than most of us here, I'm talking not even so much about millennials, but look at the impact there. 6 degrees Fahrenheit of change. The Gen Alpha, in case you don't know, I had to look it up. These are people that basically are less than 10 years old, and some of them haven't even been born yet. Look at what they're going to have to deal with. We're being impacted already, and this would be what they have to deal with if we don't make change. On the flip side, if we do make the significant changes that we are talking about as a global community, this is what it could look like. There will still be significant impact on generations of people that are alive now, but we will start to go the right direction. And when we think about what we want to leave our children and our grandchildren, and you think about this versus this and some of the things we've talked about, what it means, the things we've already seen, but that they would accelerate further, I think it makes it a little bit easier to at least contemplate making the tough changes that need to be made. So in conclusion, it's simple because it's well understood science. It goes back to the 1800s. It's serious because we are already feeling it, and we're feeling it accelerate, and it will continue to do that. But it is solvable. We have what we need to make changes. I have to give a quick thank you to Scott Denning, who is a great guy that works at Colorado State University, helped put together some of these slides and the framing, simple, serious, and solvable. And before I open it up to questions, when I would talk about climate change, invariably the first or second question I would get is, what can I do? So instead of trying to answer them verbally all the time and people trying to jot them down, I came up with a slide. Feel free, if you're here, to take a picture of this slide, whatever you want to do. I don't care. You can email it to whomever you want. You can put it on any social media platform. I don't care at all. But I want to briefly go over them. 10 things that you can do to combat climate change. Before I do, though, I referenced this at the very beginning. I said this is a presentation of facts, because it has been a presentation of facts. We're stepping over a line here in answering the common question, what can I do? We're stepping over the line. Whenever you're talking about what can be done, you're essentially talking about policy. And when you're talking about policy, you're talking about politics. You're not talking about science. You're talking about how you use resources and how people behave, which is not the same thing as science. So having said that, I just want to make it really clear that this is different, but I bring it because it's asked so often. So in my opinion, these are not generally ordered, except I did put number 1 as the one that I think is the most important. It's talk to people about climate change. Do something yourself. Do something, even if it's simple, and use that as a jumping off point, and coming to this presentation would certainly count, to then talk to people about climate change. Do you have to show a bunch of graphs and have pointers? No, you can start with what you've seen and what you've noticed and what you wonder and what you have asked and what you've looked into. It doesn't matter. Talk to them about climate change. Survey after survey shows that a majority of Americans are really concerned about this issue, but less than a third of them ever talk to anybody about it. Why is that? I don't know. I can think of a few reasons, maybe, but they don't. So just start a conversation with anybody that you can and just talk about what you know or what you've noticed. The more we talk about it, it changes what ends up happening. All right, and then planting trees. Talked about that earlier. It's getting into the time of year when we start thinking about that anyway. That's great. fly less, and or you can purchase carbon allowances. Here is one website where you can do that. There are others. That's one that I have checked out and use. If you are still going to fly but want to offset your greenhouse gas emissions, you can do it in a way like that. Eat less meat and dairy, trying for locally produced food. That saves a lot of resources. Primary among them is water, but not only water. It saves a lot of emissions to eat locally produced food. And then there's these three that I put save money, because that's always a fun thing to do too, but you can also reduce greenhouse gas emissions by leaving the car at home whenever you can, reduce your energy use, and just jumping down to number 8, cut your consumption and waste. I was shocked to find that globally, almost 10% of greenhouse gas emissions come from food waste. That's more than Western Europe produces as an entire region, food waste. So if you can do that, it makes a difference. I'm going to go back to number 7. If you are fortunate enough to have funds to invest responsibly with climate change in mind. Go to Google, type in Michigan groups tackle climate change or something like that, and you'll get a lot of local groups, because different people want to do different things. If you do something like that, you can find a group that maybe has a good match with what your interests and strengths and history might be. And then, of course, during the voting time of year, vote with climate in mind. It's a good thing to do. And before I answer questions, you can reach me at weatherchris.com. That is a very simple website that is simply devoted to talking about this presentation or ones like it. If you know anybody or anywhere or any group or anything else that you think might want to have me talk to them, please go to weatherchris.com. You can reach me through that. And then I'm also on Twitter, which is on the website, but I'm also on Twitter, at least for now, at that particular handle. So with that being said, thank you for your patience as I went through a lot of slides. I admit it's a lot of material, but it's a big subject, arguably about the biggest that we can deal with, and I'll be happy to take whatever questions you have.
Okay, what's a carbon allowance?
A carbon allowance is basically what they're doing is they are offsetting the production of, and actually I have some paperwork on this. They are offsetting the production of carbon, an impactful alternative to the offset market. Each allowance has a traceable serial number. By aggregating the demand for allowances, we enable companies to bid against utilities, power plants, and other regulated entities for a limited supply of available allowances. There's a certain amount of pollution allowance that you have. Once that allowance is purchased, it cannot be used by a power plant to emit carbon dioxide. That is essentially what they do. And if you would like to...
So that goes along with invest responsibility.
Similar, not the same thing, but they're similar. You feel free to take a look at that if you'd like. That's more about carbonlighthouse.org. But invest responsibly can mean, for instance, asking yourself the question, do I want to invest in companies which extract coal and oil and natural gas and profit from them? For instance, you can ask yourself that question. Those sorts of investing responsibly decisions are separate from this, but certainly related. Yeah. I'm sorry, you had a question.
The Great Lakes, how are they being impacted?
Great question. I'm glad you asked, and I think I'm sorry.
Before you answer, could we
Aubrey.
have a microphone?
Well, I just wanted to know how the Great Lakes are being impacted by global change, climate change.
I'm glad you asked, because there's been a lot of research, especially lately, about that, and the simple answer is that what we have seen happen with the Great Lakes and what we expect to continue happening is that their levels will fluctuate more quickly than what they used to do. We can't say they're going to go up, we can't say they're going to go down, because they're going to do both. They're going to go up, and they've always done that too. The Great Lakes levels have always fluctuated. But all the models, the sophisticated models that are working on that now, are showing us that the rises and falls in the lakes are going to be more rapid than they used to be. So instead of course, there's no, instead of seeing this kind of thing with the levels of the lakes, we're going to see more of this kind of thing, okay? And the lakes, just over 2 years ago, were near record levels, and they have fallen in the last 2 years faster than we've seen them fall in a long, long time. What's going to happen in the next year? Don't know. It depends on a lot of things, precipitation and temperatures and all that. But what the research is showing is going to happen is what has recently been happening. Lots of fluctuation. Thank you for asking. And by the way, we're waiting for Aubrey with a microphone, not so much so that we can hear each other, because thankfully we can, but this is being recorded and we want the recording to be able to hear the question as well as the answer. So thank you for understanding that and for being patient for Aubrey, who moves fast to get to where you are. Other questions? On the topic of timely things, just a week ago Monday, we had a report issued by the UN, which is a very, very big report. We don't get these reports very often. In fact, the next one will not be issued for another 5 years. It's 195 nations around the world worked to put this together, worked to agree on it. Their scientists all got together on what this report would say. And I mean, the actual report is many hundreds of pages long. Even the summary is about 37 pages, so it's not an easy read. But here's the gist of what they're saying. The goals that we've set previously about what we need to do, we need to accelerate them a little bit, maybe more than a little bit, because in the last 10 years we haven't done quite as much to reduce emissions as we hoped we would do. Now, are we moving in the right direction? I showed you that one slide that showed that we here in Michigan are reducing our emissions from a 2005 baseline. We are. But one of the quotes from one of the lead scientists was, we're walking when we should be sprinting. So we're moving the right direction, but we're not doing it quickly enough. I talked about trying to keep it under that 3 degrees Fahrenheit. On the path we're on, which includes some reductions, but on the path we're on, we're going to hit that mark probably by the mid-2030s. And it's not like we hit that mark and all of a sudden, immediately, there are massive changes around the world. It doesn't work that way. But the closer we get to it, the more impact we'll see, and the more we go above it, the more continuing impact and lengthy impact we will see. And we've been trying, when I say we, I'm talking about the global community, the IPCC, which controls these sorts of things as part of the UN, has been trying to keep us below 3 degrees Fahrenheit. That has been the goal, especially since the Paris Climate Accord was signed in 2015. Been trying to keep us under that goal. And it's sneaking up on us pretty quickly. And in order to get the goals that we set before, we have to accelerate change. That's why when I talked about how GM said we're going to be an all EV fleet by 2035 and net zero as a company by 2040. Some companies and some countries have recognized that as ambitious as the goals might have sounded when they were released, they need to speed them up. And they're doing that in some cases. And so I stand here to tell you that I would not be surprised if companies like GM speed up those targets, because what this report, among others, is telling us is that although we are moving the right direction, we're not doing it fast enough. We need to make more changes, and we need to do it more quickly. Any other questions?
I've got one. Can
Yes.
you explain on your slide early on the reason for the methane uptick around the year 2000?
The short answer to that is no. Not because I think there's anything questionable or about that data. I don't know that data set well enough to be able to answer that question. I wish I did, but no, I don't know. It's a good question.
The data's there, the methane went up, and it went up faster.
Yeah, I recall there was a time period where it was sort of relatively level, and then it moved up pretty quickly. No, I don't know why.
The point is that happened in 2000, okay? And all the other, the temperature upticks and stuff have been happening since 1940, 1950. What's gone wrong with methane?
There are a number of theories about that. I will throw out just two. One is that one of the solutions we've come up with is to use natural gas instead of coal because it produces about 50% less greenhouse gas. Okay, and natural gas does produce fewer greenhouse gas emissions, but natural gas is about 80% methane, and some of it escapes. It leaks, not just out of gas stoves, but in transportation of the natural gas and in extraction of the natural gas, it leaks. That is one theory for the uptick in atmospheric methane concentration. The other, unfortunately, is actually a little harder to combat, and that is that in Arctic regions, a tremendous amount of methane is trapped in frozen ground, tundra. And as that ground thaws, which unfortunately it is, it releases mass amounts of methane which have been trapped for centuries into the atmosphere. So those are potentially two of the major drivers of the changes in methane.
The thawing probably hasn't gotten that much worse. I mean, it's been melting for a while.
Yeah, but remember, 2 to 3 times more rapid warming at the poles than what we're seeing in this part of the world.
So we're melting more there. But
yes,
the generation of electricity from natural gas, it seems like that's something that you point at the year 2000 as, more so than warming at the poles.
Yeah, well, again, I mean, in 2000, we weren't seeing as much methane release from tundra as we're seeing now. That is true. But you have, many things that are going into it. And, as we saw with the temperature data in relation to CO2, there can be little gyrations off the trend line, which can be attributed to a lot of different things. Sometimes we understand them and sometimes we don't. But I agree with you that I think it's likely that there's more than one contributor to explain that sort of change. Other questions?
I've got another. The 3-degree increase that is being targeted, when did that first come out, roughly?
That was roughly...
Way back?
No. Well, okay. It was codified, if you will, in the Paris Climate Agreement in 2015. Okay, that is when the international community, 195 countries, set it as this is our goal. Climate scientists had been looking at that number for a long time, but it was relatively arbitrary. There was a lot of good science based on it in terms of manageable on one side of that, starting to get pretty unmanageable on the other side. And they continue to work on that and try to understand the significance of that number. But in terms of policy, international-based UN policy, it was after 2015 that number became a big deal.
But scientists probably have been putting that number out since 1990.
I don't know if it's quite that long off the top of my head, but for a while. Yeah, I don't know about 1990, but yeah, for a while. Mm-hmm. Because the first UN reports on climate change came out in the 80s.
Here's my point, is that I bought a used science book at a library, and its copyright was in the 90s. Mm-hmm. And I read the section on Earth and climate, and a lot of those goals that you hear today were in print in this book from the 1990s. And my only point is that or not my only, but the point is that those goals would have been established at a time that we talk about industrial production causing the CO2 to go up. Those goals were out there at a time when world population was maybe 5 to 6 billion people, and now it's 8 billion people. How in the world are you going to make a reduction that's going to be effective when there's 25% more people?
Right.
The cuts are going to have to be so draconian. That's what I feel.
Okay. Briefly to address the population issue, because I understand what you're saying. We have to remember that even though there are 8 billion people on the planet now, which is a lot more than there were in the 90s, the massive majority of those people live at a much lower standard of living and produce far fewer greenhouse gases than those in the highly industrialized, generally rich countries. So my point is that even though we have a whole lot more people, billions and billions of those people are producing extremely low levels of greenhouse gases. And most of those people that have been added are in those countries where those levels of greenhouse gas emissions are lower. And you can express skepticism about that, but there are many sources that talk at length about that. And very briefly, I just want to talk about a couple of books because we're in a library, and I like to reference certain books that people can read to get more information. This is called the Carbon Almanac, which was just published late last year. This is The New Climate War by Michael Mann, largely about some of the political and scientific applications of the climate science. And Saving Us by Katherine Hayhoe is dedicated mainly to how to talk to people about climate change. But I reference, and by the way, One Shade Greener at Home. You guys can all look at this on your way to, if you'd like to, any of these books. But the Carbon Almanac talks a lot about the issue that you're discussing and recognizes that two things have to happen. First of all, we have to understand that many of those people that have been added in the last 20 or 30 years are not producing much in the way of greenhouse gas emissions, number one. And the second is that billions of people, literally billions of people, can have their standard of living raised and bypass the fossil fuel stage that we used because it was cheap and available and we didn't know as much about it, we meaning we, the already industrialized rich nations. Those nations can still bring up their standard of living and not necessarily have to use, or at least use to the greatest extent, the coal, oil, and natural gas that we have used over the last 150 years. That's part of how we respond to the fact that, yes, there are 8 billion people, and so it's different draconian cuts that have to be made. I guess that depends on how you define that and what you're cutting from. What you're cutting from. There's no doubt that some countries will have to cut more than others. But it's also, when I talked about the unfairness in the generational charts, there's also unfairness in a national scale. This is what we're putting on the backs of the generations behind us. There's another way to look at whether or not there's fairness, and this is what makes it very complicated from a political standpoint, is that many countries that are producing very few greenhouse gases are severely impacted by this. And that makes it really tough, really tough. In the core, the most important thing is that the obstacles that we have really aren't physical or technological. We have the technology. These are political decisions that have to be made, and there has to be a three-prong approach. I'd rather go to what we can do. There has to be a three-prong approach to make the change that needs to be made. It has to be individual. I don't want to downplay for a moment the importance of doing your own part in your home, in your town, in your area. But that's not going to be enough. There also has to be corporate change and there has to be governmental change. And all three of those pillars, all three of them are going to be needed for us to meet the goals that we're trying to meet. Yes. Oh, here comes Aubrey.
Can you talk about the use of lawn equipment? Because I thought I'd heard that our use of lawnmowers and growing grass, very inefficient.
Gas, yes, I can. Gas-powered lawn equipment produces quite a bit more CO2 than you might think. And that's, I'm not going to so much get into the green grass in general because it does have some benefits in terms of helping the atmosphere, but I will say that when we run a gas leaf blower, a gas trimmer, a gas mower, not only are we adding to the ozone problem, which is air pollution in the lowest levels of the atmosphere, but we add to the greenhouse gas. We add carbon dioxide. So the simple answer to that is, if possible, when possible, go to electric. I mean, My son bought a house a couple of years ago, and he said, Dad, from the get-go, I'm not buying anything but electric, and he said most of the people my age are doing the same thing. They're buying electric lawn tools. They won't use anything else because they recognize the difference. It is significant what they can produce. Again, not just one or two, but when you do it all over the place for large periods of time in the growing season, it does make a difference. So making a switch to electric is a good switch. Now, ripping up a lawn and replacing it with AstroTurf or concrete, not necessarily a good idea. It's pretty radical, it's extremely expensive. Concrete production produces a lot of greenhouse gases as well. But if you can use electric lawn equipment, that's one of the little things that can make a difference. Yeah. Other questions? All right, well, if anybody has any questions that come up in the future, I again want to direct you to weatherchris.com. You can just shoot me an email because maybe you think about something in the future, or as I said, if you know of a group, gathering of any kind that would like to hear about the latest about climate change, I would certainly be interested in talking to such a group and see if we can do a little bit more of number one, talk to people about climate change. But I want to thank everybody for being here, for taking part of your evening to come here, for being interested and engaged. It's not an easy topic. Even though it's simple, serious, and solvable, it's not necessarily easy to get your arms around. But I do want to leave you with an optimistic tone, because I do think we still have an opportunity to make the change that needs to be made without radically changing our lives and our lifestyles. But we need to move and move soon, and we start by talking to each other. So thank you for your time, and I'll be here packing up my toys for a little while. Thanks for being here. Thank you. Thank you.
Thank you for watching our presentation. In order to discover upcoming events at the library, please visit our website, westlandlibrary.org, and click on our events calendar for a full list of everything that we have. You can also visit our Facebook page at Westland Library for daily updates. Thank you for watching, and we hope to see you soon.